Okay, for assignment 1, star pattern, let's see. Yeah, this one is pretty straightforward. We have 8 vertices, as we can tell. I label all the position of those vertices. Uh, the bitewise has to be 8. Uh, and for the winding, I also label all my winding triangles right here. So we have 6. We're supposed to have 6 triangles in order to draw this pattern. So red triangle 0, 0, 4, 7, top one, and then left one, then bottom one, and we have this one. You can treat this middle middle portion of this star as a square, and we divide this into 2 triangles. So 4, 5, 6 for the left, and 6, 7, 4 for the right triangle, and for the bitewise of for the size of indices, we have 3 times 6, which is 8. Uh, yeah, and that's how we get our star. So for the next one, inside polygon, let's see. This one is a little bit complicated. Yep. For the vertices, now we have in this case have 12 number of vertices. So in order to make this dynamically, we have to set up an array, and in order to get those coordinate of each vertices, uh, we need to find the angle between our origin point to each vertices, and this and the formula is 2 pi times our loop. We set up a loop uh, for for our vertices, and so 2 pi times loop over the number of vertices. That's how we get our angle. And since we have angle, we just need the x value is basically the cosine angle times this constant value, and sine angle times this 0.5 constant value. That's how we get each vertices coordinate. And the size of vertices is 12 in our case. For indices, so I did a little search up online, and I realized uh, for inside polygon, in this case 12, we have like 10 triangles if we want to construct this polygon. So this is why we have like 3 times 12 minus 2, which is give us 30 indices. That's how I get this number. And if you make a so for the winding part is the most complicated one. But if you start counting those indices, you will find out that so for the first one, 0, 0, 1, 2. The next one, 0, 0, 2, 3. We start to have this pattern, and that's how I got this code here. And for the size of our indices is 3 times, the number of 3 times 10. Uh, that's how I got this inside polygon. Okay. Further work for question number 1. So if we change our top vertex value, z value to be 1, it will be still the same because we set up the depth value, like maximum depth value z is 1 and minimum is 0. But once we set up this value to 2, we will see this trapezoid because it get clipped at the clipping stage of the pipeline, since uh, so this is the top vertex is no longer be shown. That's how we get this strange behaviors. For question number 2, um, if we want to render something else than full window, we can change top left x, top left y, width and height value, so that we can reach our goal. For question number 3, this format basically means, uh, you know, red, green, blue, alpha stands for the color value. Each with 4 component, 32-bit unsigned normalized integer format. That whose value are in range of 0 to 1, and also divided by 255, I think. Yeah. For this one, it means now we have a 16-bit unsigned integer format that support 16 bits for the red channel, uh, and signed integer, and this one simply stands for signed integer. Uh, it means we have like 2-byte unsigned short data type to store the triangle indices, and yeah, that's it. Thank you.